So we're going to talk about multiplying decimals, and let's start by multiplying whole numbers and see how it relates to multiplying decimals. Hopefully you all know what 7 times 3 is. 7 lots of 3 or 3 lots of 7 are 21, aren't they? In this video we're going to talk a certain amount about multiplying and dividing numbers by 10 or 100 or 1,000, and if you want to get the most out of this video, then you'll want to understand what happens to numbers when we multiply by 10, 100 and 1,000. We're going to talk about it, but not in great detail. So if you're not sure about that, you might want to go back, check that one out, and then come back. But anyway, let's take this number, this sum here. 7 times 3 is 21. I think we're fairly comfortable with that. Let's adjust the numbers in the sum a little bit and see what happens. If I made this number 7 10 times bigger, 7 times 10 is 70, right? So if we then said, okay, well, what do we think 70 times 3 is? Instead of 7 times 3, what's 70 times 3? I reckon you're probably all comfortable saying that the answer is going to be 10 times bigger as well, because 70 lots of 3 is 10 times more than 7 lots of 3, isn't it? So we should all be comfortable saying that the answer is 210. Similarly, if we just scroll down a little bit, if we make this number 10 times bigger, 3 times 10 is 30, so that would give us this time 70 times 30, and you ought to be comfortable with saying that if we've made the 3 10 times bigger, then there will be 10 times more of what we end up with, because 70 lots of 30 ought to be 10 times more. 70 lots of 30 ought to be 10 times more than 70 lots of 3. So we ought to get this time 2,100. And we do. Now, that's obviously there are no decimals there, but what we're doing here is we're adjusting numbers, multiplying them by 10, or I suppose if you went from the 7 to the 70, you could, and from here to here, times it by 10 here and times it by 10 here, means our answer has actually got 100 times bigger. This is making the numbers bigger, but let's explore what happens when we make the numbers smaller, starting again with our 7 times 3 is 21. If I divide 7 by 10, 7 divided by 10, you should be, and this is where I come on to our talking about moving decimal points around, you should be comfortable with saying that 7 divided by 10 is 0.7, because the decimal point in 7 when we divide by 10 can be said, can't it, to move one space to the left, which will give us 0.7, or as we call it, 0.7 in this country. And if we had 7 lots of 3, and we've now got 10 times fewer lots of 3s than that, we've got 0.7 lots of 3, then in theory, if what worked on the previous page works again here, then our answer should be 10 times less than the original answer, shouldn't it? Because we've got 10 times fewer lots of 3. So 21 divided by 10, again, we take a decimal point, move one space to the left, and that gives us 2.1. So 0.7 times 3 will be 2.1. And I wonder, how about, do you reckon you can work out what will happen if we divide the 3 by 10 as well, to give us 0.7 times 0.3. So instead of 0.7 lots of 3, this time we've got 0.7 lots of 0.3. We've got 10 times less. Which you got it. It means our answer will be 10 times less as well. So 2.1 divided by 10 should be, and it is, 0.21, because again the decimal point moves one space further to the left. And so we're left with a calculation of 0.7 times 0.3 equaling 0.21. There's an example that sort of relates multiplying decimals to multiplying whole numbers together, and hopefully you can see the explanation as to why this answer at the bottom is the answer it is. Even if you're not clear about that, here is a mechanical way of being able to multiply decimals by whole numbers or decimals by decimals. So let's go back to that last answer that we had, last question we had, 0.7 times 0.3, and we had an answer of 0.21, didn't we? And there is something you'll notice here that will help you. How many decimal places are there in the question? 0.7 times 0.3. Decimal places are digits that come after the decimal point in a number. So in 0.7 there's one decimal place, there's 7 here, and in 0.3 again, the 3 is another decimal place. So altogether there are 2 decimal places in our question, and we will note, if we look across to the answer, that in the answer there are also 2 decimal places. And that actually reflects the fact that when you multiply decimals together, let's do another one, when you multiply decimals together, if you simply count the number of decimal places that there are in the question and make sure your answer has the same number of decimal places, then for the purposes of your calculation, you don't need to worry about the decimal places and the decimal points. You can simply multiply the numbers together as whole numbers. Here's another question. 0.09 times 0.3. How many decimal places? Well, there's 1, 2 here because they're after the decimal point. And here's the decimal point in the other number. And there's a third decimal place there. So we have 1, 2, 3 decimal places. If we make sure there are 1, 2, 3 decimal places in our answer, then we can be sure of having the right number of decimal places. Having done all that and thought about the decimal places, we can now multiply these numbers together as whole numbers. So that gives us 9 and 3. So if we do 9 times 3, which is, even my son Tom knows that one, 27, then we can take that 27 and drop it in some space we prepared over on the right for our answer. We take and we fill up from the right hand side. So the 7 goes there, the 2 goes there. We've got a blank space here. We need another decimal place. What can we put in there to keep that space filled? We'll have to occupy it with a 0, won't we? So we get an answer of 0.027. We had 3 decimal places in our question. We have 3 in our answer. And 9 3s are 27. Here's another one to show you that you don't always have spare spaces left over. How about this one? 3.62 times 0.7. Okay, again, how many decimal places is the question? 1, 2, oh, it's 3 again. Great, okay. So we'll make sure there are 3 in our answer. And make sure you've got a decimal point there as well, otherwise it's a bit silly, won't it? And then we multiply both the numbers in our question as though they are whole numbers. And we take all the digits of both numbers. So it's not just the 62 here, it's 362 times 7. That's very important. Quite a common mistake is to ignore the 3 that comes in front of the decimal point. You don't. You take the whole number and treat it all as a whole number. So we've got 362 times 7. And here we go. We can write it out like that if we're not sure about it in our heads. 2 times 7 is 14. 4 carry the 1 across. 6 times 7 is 42, plus the one we had here, makes 43. 3 carry the 4 across. 3 times 7 is 21. 21 plus the 4 underneath makes 25. Put it 2 straight there because we're done, aren't we? We've got an answer of 2,534, but we have to remember the decimal places, so we take our answer and we drop it into our spaces over here, filling up from the right-hand side. So the 4 goes there, the 3 goes there, the 5 goes there, and the 2 will go across into the units here. So give us an answer of 2.534. It's not out of the question. Your answer could end with a 0. Let's just look at that for a moment. Let's look at 34.2 times 0.005. How many decimal places in our question? Easy. 1, 2, 3, 4. Make sure there are 4 in our answer. Preparing your answer. And then multiply both numbers as whole numbers. It's not just a 2 on the left, it's all of that. So it'll be 342 times 5. 342 times... You could write 0005, couldn't you, in case you're wondering. You could write all that stuff, but those zeros serve no purpose, do they? Because if we times anything by 0, we get 0 as an answer, so it won't add anything to our answer. So it's just multiply by 5. 2 times 5 is 10. 0, carry the 1. 4 times 5 is 20, plus our 1 underneath is 21. Put the 1 there and carry the 2 across. 3 times 5 is 15. 15 plus our 2 here is 17. We can put the 1 straight in because we're done. And we get an answer of 1,710. So we'll pop our answer over here, filling up from the right. We go 0, 1, 7, and a 1. And we put a 0 there in front of the decimal point. We get an answer of 0.1710. And as I said at the beginning, here's a question where the answer ends with 0. If you were writing the number 0.1710, would you write it as 0.1710 if you were a grown-up? You probably wouldn't, would you, unless you had a good reason to. You would actually just write it as 0.171. That's 0 in the last column in the 4th decimal place. What's that? That's the 10th, 100th, 1000th. It's a 10,000th. That 0 serves no useful purpose, does it? And so there's no point in putting it in our answer. It's not wrong. It just doesn't add nothing to the meaning of our answer, and so we will probably omit it from our final answer. But there we go. When the numbers end with, when your answer ends with a 0, you just make sure you include your 0 in your answer, in your decimal places. It counts as one of your decimal places, but you just don't need to mention it in your final answer. So although we thought said there'd be 4 decimal places in our answer, and there are here, in actual fact our final answer ends up with only 3 decimal places because that 0 is not relevant, and we can omit it from our final answer. It doesn't change the number. Okay, that's multiplying decimals by decimals, and of course the same thing works for, I'm doing lots of 300s, lots of threes here, aren't there? Why don't threes full in my head at the moment a lot. You could do the same thing multiplying a whole number by a decimal. You could count the decimal places, there's just the one here, isn't there? Because 354 already is a whole number, and multiply away. 4 8 to 32, carry the 3, 5 8 to 40 plus the 3 makes 43, carry the 4, 3 8 to 24, 24 plus 4 is 28, and there's your answer, 283.2. Why is our answer, 283.2, smaller than the number we started with, 354? You wondered that? Well, the answer is because we're multiplying by a number that is less than 1. We have got here less than one lot of 354. Less than one lot of something is going to be less than that something, isn't it? Less than one whole pizza is going to be part of a pizza, isn't it? So less than one lot of 354 is going to be less than 354, and that's why we are ending with an answer that is smaller than the number we started with. And you might have wondered that earlier with some of our other answers as well, especially these ones. I suppose 0.7 times 0.3, you're thinking, well, hang on, 0.21 smaller than both those numbers. Well, yeah, it is, you're dead right. And that's why, it's because we're multiplying by numbers less than 1. When we do that, our answer becomes smaller, not bigger. So there we go, multiplying by decimals. Count the number of decimal places in your question. Here there were 2, 1, 2, and make sure there's that number in your answer. 1, 2. Here we had 1, 2, 3, so we had to make sure there were 1, 2, 3 in our answer. If you only have a 2-digit answer and you have 3 decimal places, then you can insert zeros to act as placeholders. You've been doing that since, I don't know, roughly year 2, haven't you? When you started understanding about tens and hundreds, you've been putting zeros into whole places. And that's it. It works the same when you're multiplying 2 decimals as it does when you're multiplying by a whole number and a decimal. It's a perfectly sound method that works really well. Okay, so there we go. That's multiplying decimals. Good luck with that. Good luck with that.